Here. Okay,
Yeah.
good.
All right. Let me see. We have about 22 people, and we can wait for 1 or 2 more minutes. Yeah, Prof.
Sure, no
Yeah.
problem.
Okay.
So by this time we can ask people if anybody was able to download the software G Power. Is it's free. Um, and
Yeah.
Doctor,
sometimes, yeah.
hello, doctor.
Yes, Yusuf.
Yes,
I was download the G Power version 3.1.
excellent.
It it's free. There is no any extra money or extra points needed. Now it's
Exactly.
functioning.
Very good, very good. Thank you. So I think it should work. I don't, I didn't see any problem. They changed the version. I think 3.1 or 3.12, something is the latest one. So anything will work. So please try your PC if you have it here with you. As I go with the data to calculate sample size, if you want to try with your own computer, you can do it along with me. And if you have any issues, you can just let me know. I want to really do this session very interactive, you know. Sample size is something, is not theory, it's just practical. We need to do it. Unless you do it, you'll not learn it how to do it. So that's very important thing too. That's why I thought it should be an interactive session. Wish I could go there and really go like a session that I have done it before in Kotavaru.
Yeah.
Um,
Agreed.
Sometime it will happen. Sometime, if our project is approved for the clinical trial,
Yeah.
maybe you will have more chance
Yeah.
to go there and really do many research sessions together with
Yeah.
our
If
participants.
we get you here, then you will be busy. You will make sure you are having more time with the participants, hands on.
Yeah,
That would be more interesting.
yeah,
Okay.
you know,
Let
yeah,
me.
just 1 second. I want to tell you this.
Mm,
With this experience that I'm getting from you, this is helpful for me also, not just you, because going to start a similar program in Bangladesh
mm,
starting May, first week of May.
mm.
So they are very much interested. They have already announced everything there. Your professor that now he is doing this with me.
Prof. Ashraful Haq.
Dr. Ashraful Haq.
It's
Yes.
he was my teacher many years ago.
He's a great teacher. He retired, but he has taken these things with me
Ah,
to educate people in Bangladesh.
okay, that's great. Okay, Prof. We are now 3 minutes past 10. We have about 32 participants, and I think some will be joining as we go along. And this session is recorded, so we will upload the recording into the PPSK YouTube channel. So you can revisit the recording, or you can share the recording to the our colleagues who are unable to attend due to work commitment or other issues. Just to recap a bit about our session, we had sample size calculation part 1. For those who have missed that, I believe Puan Wan Suryati has uploaded into the PPSK YouTube channel. Today we are going to learn on part 2, and I've been told earlier by Prof. Amal that he will drive you all to learn more about G Power, which is a software free of charge, which will help us to calculate sample size. Before I pass to Prof. Amal, I just want to share with you, I think sample size, some people say it is not important, but actually it is very important, not only for the quality of the research, but also when it comes to the ethics committee. When you go to the ethics committee, there will be a person who will be looking at that, whether did you do your calculation correctly, or the number are reliable, or etc. So, Prof. Amal, I will pass to you. I will try to stay tuned, but if I had something on, I will need to leave. So I will update one Suryati if I'm not around. But definitely, I think the participants will be learning a lot from you, from your experience. And thank you for your time. And I would pass the session to you now, to you, Prof. Amal.
Thank you so much. So this session, as I said, it will be interactive, and I expect that if you face any problem, any issues, you just tell me. If I do not see the chat box while I'm talking, because there's two things we cannot operate at a time, you please raise your voice and tell what is your question and what is the problem. Okay, so I'm trying to share my screen. So I minimize my picture here. Okay. Okay. I want to see the whole. Okay, let me see. How do I go to the full
It's at the bottom right.
box on the right? Okay.
Bottom.
Bottom right. Okay,
Yeah.
let me see.
There is a screen.
Oh, no.
Next to the volume. Next to the Zoom.
On the bottom?
Yeah, that image.
Why
Yeah,
I
that
don't
one.
see.
The first
I
one from right.
first one from the right. I don't see that. Why I don't see that? Okay.
Yeah, that one. Your cursor is there now.
You cannot control that?
I'm not
Can you
sure.
make it
Suryati, can we take over control?
or just can you let me see? I'm just trying to where is the
It is you know the orange bar at the bottom?
I don't see that.
You don't see the orange bar.
Now let me see.
Or go to view. Go to view
Hmm,
in the middle. View.
middle view.
Yeah,
Okay.
view.
Yeah. Okay. Okay. Then
Views.
where is the full
Yeah.
slideshow? Where is the slideshow? Slide master, slide sorter,
Oh, it's not here.
normal. Why do we see the?
No. It's actually in the orange bar down there.
This is normal.
Hmm.
This is outline view, slide sorter, note page, reading view, slide master, handout. Let me
Press
see.
the F5, Prof.
Hmm?
F5. Someone, Sidra
F5,
suggested F5. Yeah.
F5. Ah, thank you.
Thank you, Sidra. We learned something new about PowerPoint today.
Yes. I don't know why this is like this. Okay.
All right.
Anyway. So thank you again. So let me go to the second. So those who missed the first part, basically I talked about one type of sample size estimation, uh, mm, and that is for cross-sectional studies. I'll continue that, but there are different kinds also. So few basic things. Professor Hamidjan told you about the importance of sample size. So if you want to answer something, I want to hear from you because I wanted this to be interactive. Why do you think that calculating sample size is important to you? Anybody can answer, please. Just one answer. Any. So in doing, I'll not spend much time, just wait. because we have very only 1 hour time, so we have to finish everything on time. So basically, you need to calculate sample size. Without that, you shouldn't do a research. I should say you shouldn't. I give you an example. I was in IRB committee, Institutional Review Committee at my university, and someone submitted a project, and he wanted to study 27 or something, less than 30 samples. And he didn't justify why. Then we call the people when there is a problem. We call the guy and asked him. He's a good researcher. He's a professor. Asked him, why did you want to study 27? I said, previous studies did like that, 25, 23. I did a little bit more, 27. So that's not the answer. If previous studies did wrong, do you want to continue similar mistakes in your study? Definitely not. So is there any magic number of sample size that you should study? Some people say 30 is a magic number, but I do not buy that. I want to really see what is the required sample size. So if I say, okay, I'll study 500, is it good enough? There is no answer to that. What is good, what is bad, that comes from some calculations. So if you think I'll study 1,000, so how about 1,000? It should be good enough. It is also not good if you study too many subjects than what you require. That is also not good. Why it is not good? Because every number matters, because it costs some money. If you include 10 more than what you need, you have to calculate how much money you are spending for extra 10 people. Is it required? If you do not gain much from your study by increasing the sample size than what is required, please try to minimize that. You can increase some, but not a big number. For example, if you need 400, you may go up to 500, but not 400 to 800 or double the number or 1,000. That's you are really increasing your cost of the research. So that's why we need sample size, but it depends on many factors, okay? One factor is type of study. What type of study are you going to do? If it is a cross-sectional study, my focus today and previous lecture was cross-sectional because that is the main or majority type of study, does cross-sectional studies. So there is one type of sample size estimation for that. I couldn't complete everything about sample size in 2 lectures. That's why I limited with cross-sectional study only. But if you want to know more about it, you can write to me. And I have plenty of examples that I can give you. So if you do a case control study, I hope you know about case control study. Anybody want to say something that you know about case control study? Any person? Please quickly answer to me. What do you know about case control? Yeah, I see that. Please tell me, what do you know about case control? It calculates, very good, very good. Thank you. He says it calculates odds ratio. That's what I wanted to know really, because case control, we have a case and we have a control group, and then we look for their risk factors or exposure factors in the past. But the main thing that we calculate, yeah, Yeah, you said healthy and unhealthy. So that is one type. I do not go into depth of that because healthy, unhealthy is one way of getting case and control. Uh, but I do not want to go into depth. I can talk, I mean, there are many ways we can do it. But thank you for the example. So odds ratio is the statistics that you can calculate for case control study. So if you want to do sample size for case control study, you have to use odds ratio. Similarly, cohort study is a forward study, longitudinal study. Anybody can tell me anything that you want to calculate for cohort study? What statistics? What type of statistics? Yes, I think I got a good participant who has experience, and he said, yes, risk factor or relative risk. Some people call it risk ratio. So relative risk, yes, that's the real term we use, relative risk. So to calculate sample size for cohort study, we have to use relative risk. I do not spend only on sample size for many lectures, but really, if you are very interested, I can offer another session for sample size just for case control and cohort studies and clinical trials. So clinical trials is another thing that's very important, and Professor Hamid Jan and me involved in that study will be offering a clinical trial if it is funded in Malaysia. Professor Hamid Jan, you want to talk a little bit about that project, just one or two sentences?
Yes, Prof. Yeah, it was a project with Friesland Campina in Netherlands, and we were having some issue with the study design and sample size, and that's when I approached Prof. Amal to improve the proposal. And it is a good news. Actually, the proposal is accepted, Prof.
Okay.
Yeah, the both parties have signed the agreement. But the only thing is the money has not come to USM yet. So they are working with the finance. So once we will have the money in, we will start to work on the protocols.
What about the IRB? Is done?
Not yet. I'm going to send to all the members the final draft of IRB. Once we are all happy with the draft, then I will submit to the USM ethics for approval.
Okay. In USA, we do not need a full version of the project to our IRB. We just summarize 2-3 pages for IRB. I don't know the protocol for IRB in Malaysia.
Or in here,
Anyway.
you want to see the complete?
Oh, complete. Okay. So,
Okay.
so other things. So this what type of study you are doing, your sample size, calculation, and formula, everything will depend on the study design. And I will also give you some references, not here today, but if you are interested, I can give you some really nice books that are available. Some are free of cost nowadays. Like clinical trial book was not free, 1984, when I started that book on a multi-center clinical trial funded by WHO. That time I got that book. Now it is free. So it's a very good book that I shared with Professor Hamid Jan. If anybody interested, we can share that too. Very, very good book. Yeah, I know. I want to know somebody wrote. So, okay, yes, I will do that. Thank you for your interest. Okay, the other thing is important when we start calculating sample size. What is your major outcome variable? There could be one or there can be multiple. If you have multiple outcome variable, sometimes we have major outcome variable and also minor outcome variables. Okay, In our clinical trial proposal, we have major and also minor. So it depends. So if you have many, you have to calculate sample size for each of the major variables. Normally, we do not calculate sample size for minor outcome variables. Okay. So and my advice when you do a research, try to limit your outcome variables, not too many for one study. Then people may criticize that it's an over ambitious protocol. So how many groups of your subject? That's another issue. For cross-sectional study is always one, but you can have multiple center to conduct cross-sectional study, but group would be always one because you are not comparing one with another. But case control, definitely two. Sometimes it can be more than two because I recommend for each case, control should be more than one. That's my recommendation. At least two, best is three, not four. Three is the optimal. Okay, please remember when you do case control study, 1 to 3 is the best design. So how many group is important because you'll multiply with that number for the total sample size. So please remember these things, okay? Next. So I'll go over step by step and then I will show you the G power, use of G power. So basically, you need to have some data, always. So first thing first, get the baseline data from which you will develop the sample size. So how do you get the baseline data? You can use published literature. That's the most common thing that we do. So if you have an outcome variable, you will try to get data for the outcome variable, each of them, if you have multiple, from previous studies. Try to get outcome variable data from your own population. If there is no data, then go to other similar population. Like if you are in Malaysia, try to get studies from Malaysia studies. If there is no, then go to neighboring countries, Singapore or other countries, okay? Then previous study in your population. So that's what I mentioned. If you do not have this, you can generate some data by doing a pilot study. We often do it. So if there is no data, if there is a new study, nobody has done it before, we have to do a pilot study. Sometime before you go for, I'm also talking about grant writing. So when you apply for a grant, if you want to do a study and that not has been done before, it's better to do a pilot study, generate some data, and then apply for grant. Nobody will give you money if there is no evidence before that you have done it. If there is nothing like that, sometimes we go for professional guess. I ask my colleagues, Professor Hamidjan, what do you think would be a reasonable number for this, or what could be the reasonable data? Like if I want to say, like breastfeeding, for example, we do not have any rate, any known data for breastfeeding at 2 years, for example. At 2 years, what percentage of people are breastfeeding? Say we do not have it. So in that case, yeah, I saw one person said 50%. That's another thing. You know a little bit more than some other people. That's good. So if there's no data, we sometimes use 50%. Thank you so much. So professional guess is another. We can ask Professor Hamidjan, what do you think in your Malaysia, what would be the rate of breastfeeding at 2 years? So it's a professional guess, okay? So we can use that too. All right, so next, we have to set up certain numbers. You see, if you ask me, calculate sample size, I can give you a sample size number. But if you ask another person with the same data and ask him or her to calculate sample size, two numbers may not be the same. Please remember that. Please remember, Dr. Mitra gives me a number 400, another person gave me 350. Why there is a difference? There are reasons why there is a difference, okay? So we have to use same numbers to come up with the same sample size. So we have to really tell what is my alpha value, usually 0.05, beta value, I'm not going to what is alpha, what is beta, because it will take time. So beta value, usually for human studies, is 0.1 or 0.2. Usually, I said usually. So then you can calculate confidence and power. Confidence is 1 minus alpha. So if alpha is 0.05, 1 minus 0.05 is 95 or 95%. Okay, so that's confidence. If you have beta, you can calculate power. Power is 1 minus beta. So if power is, and also vice versa, you can if you have power, you can calculate beta. If you have confidence, you can get alpha. So it's vice versa. Okay, so 1 minus confidence is beta, 1 minus power is beta, 1 minus power is beta. Okay, so if you have power, 1 minus 0.8 would be beta. Okay. So other thing is effect size. Effect size means what? And that definition varies according to the type of study. So in this case, how much difference do you expect from the real value? This we also called precision. This we are using for cross-sectional study. But this could be different for when we do a clinical trial. Please understand that effect size is always there, but its definition is different based on the type of study. Okay, so for cross-sectional study, we are using this definition. How much difference do you expect from the real value? From the real value means what? I want to really know what is the truth, what is the real truth in the population. Whatever my outcome variable is, what is the real number of that outcome variable in the population? That is my goal. That is my goal. So we want to reach to the real truth in the population. That's not always possible. There is always some error. That's why there is alpha error or beta error. Okay, so this we call precision. How precise your study you are expecting. More precise, better. You know that. More precise means more closer to the real value. So I give you example. If D is 5%, some people use this like a magic number, but I do not take any magic number for calculation, but I will tell you, this is the effect size I used. You must tell that. So 5% means, it means the estimated value would be somewhere 5% plus or minus from the real value. If we use D equals 4%, so it will be plus minus 4% from the real value. More smaller the D, more precise is your study. Better is your study. Better means also large sample size. So that you have to count when you use the effect size, when you use the error rates. Another factor is dropout. Dropout means once you enroll the subjects, what proportion of them would drop out of the study or do not stay in the study? Some people also call it attrition rate. So suppose dropout rate is 20%. It means we have to add 20% more, 20% more, because this 20% of the people will not stay in the study. To get the real number, you have to add 20% more to the total sample size. Okay, I take this class many level, not undergraduate, graduate level, masters and PhD level. I've seen this problem many times. They subtract this number. No, dropout, you will always add to the total, because these people are not going to stay. You need more number. Just basic things. You need more numbers because they are not going to stay the study. Okay. Any questions so far? Okay, no fixed dropout. Okay, yeah. So there is no fixed number for. I really like that you send me questions in the chat box and I can see that. Okay, please do that. So yes, there is no fixed number. So how do you know what dropout rate you should use? Any answer from you? Quickly. No idea. Okay, no problem. So it depends on, again, what type of study you are doing. Somebody says outcome. So yes, outcome is important. Let me answer it. Okay. No more answer, I expect. Okay. So 20% or 30% or 50% or 40% or 10%, there should be some way to know it. One way to know what type of study design you have. Okay, please remember, in the past, we used to do a telephone survey. Now telephone, everybody has cell phone. We still can do telephone survey with less dropout. But in the past, we had one telephone in the house and some people did not have telephone. That's the situation. We did many studies, many research, okay? In that situation, we had a lot of dropouts. And I have done so many studies before coming to the the cell phone business. Okay, so we all had one telephone and people who did not stay at home or moved from one house, and especially for poor people, they sometimes they do not have a telephone. Or in Mississippi, I have done one study which I had a lot of dropout because at that time we had Katrina. So Katrina hit many houses were demolished. People moved out from one place to another. And usually, if you work with low-income people, they really move many places, one house to another, because of their economic status. Okay, so in that case, dropout could be larger. Dropout could be larger. Now, if you do house-to-house survey, in that case, dropout would be less because you are going there. You are personally going there. Okay, so this design is important. Number two, if your questionnaire is long, people are tired answering your questions, okay, dropout would be big. So your questionnaire should be simple. And in IRB, Institutional Review Board, you really should submit the questionnaire and they will see, and you must tell Any answer? So I hear some noise. Okay, so you must tell how much time it will take to complete the questionnaire. Number one. Number two, if there is any sensitive questions, okay, people may not answer um, easily to sensitive questions, especially when there are questions related to mental health. There is a lot of issues. We are not going there, but dropout rate could be higher. So how do you get to a dropout rate? Depends on any studies that you have done or somebody else have done similar study with the population you are studying. That's the best way to do. Okay, if you know some people have done this kind of study before in the similar population, may not be the same population, but similar population, you can use that dropout rate. Okay, so again, if you do a clinical trial, because patients are in the hospital, dropout would be very minimum, okay, compared to a community-based study. And epidemiology, my job is epidemiology. Most of the time we do community-based studies where there are a lot of socioeconomic factors, climate factors, so many other issues. Dropout rate are expected to be higher than the clinical trials. Okay, so this is in general about the dropout rate. So you can do same sample size calculation either using a formula or using many of the things that you can use using G power, but not all. Okay, so it has some limitations, but it's easy. That's the most important part. And also there is an important part of G power that I'm going to show you why I like it. So this is an exercise, okay? I got this data from a World Bank report, like old report, 2018 report about rate of stunting in children under 5 years. Professor Hamidjan knows better than me about the data of Malaysia, but I'm using this number just as an example. So in 2018, Malaysia's rate of stunting among children under 5 was 21%. I actually got another big number. I didn't use that. I didn't believe that number is that high. So I used this number. I didn't give the reference here, but you can find out from the World Bank report. Okay, so P, which is our proportion of the variable of interest is stunting, is 21%. If you should convert it to decimal, which is 0.21, just always divide by 100. That's easy, okay? I get another, oh, somebody gave a reference. That's good, thank you. Keep those information because it's recorded, people can use those references. Thank you. So that's our P. Let's say dropout rate is 20%, okay? So if you use the formula, this I'm not going to use it today because this is what I did in my first lecture. I do not want to repeat. Just quickly, here G value is 1.96, which is a kind of constant, but it depends on what is your alpha value. And if you are doing a two-tailed test, if you do alpha 0.05 and you are doing two-tailed test, then only your G value is 1.96, which you will plug in here, square it. P is 2.21 that we used, or 21%, and Q is 1 minus P, that should be 0.79, 1 minus 0.21 is 0.79, very quickly. Now D, I told you, and D is how closer to the real value. Suppose we use 5%, so it should be 0.05, you'll square it. Don't forget the square, and then you get the number. But today we'll do G power. So this is the theory, but I'll go to the practice, okay? Theory is, you'll see this. Just keep this thing, PowerPoint, with you. I'm not going to use both at a time. So we'll select exact, I'll show you. Then we'll select proportion, because proportion is used for cross-sectional studies. And then there's a drop-down menu. I will select two-tail test, and you can select alpha value and 0.05. Default is there. And then there is a default for power. Default is 95% for G power, but I change it because 95 is usually too high for power. 90% is quite good number. Sometimes I use 80% or 90%, depending on how much sample size we can afford based on my money. So if you do 90%, your sample size would be higher compared to if you do 80%. And then you follow certain steps. You click on this, and then you go to another part of the formula or the G power, and there you need to do some changes. I just mentioned this, but we'll do the same thing over there in G power. Let me go there rather than going to theory. Okay, so let me stop. I'll stop sharing, but I want to share another screen. So maybe I should stop sharing and share again. Is that correct, Professor Hamidjan?
Yes, you need to stop sharing PowerPoint and then share the G Power page.
Okay. So then, so I'll go to share again, and I'll go to G power. I want to go to the main. I want to go to, let me see where it is. I want to go to my main window. So it should be, what is this setting?
You need to open the G Power first.
Now, yeah, I want to go to the main screen. So my desktop, where is my desktop? Should I cancel and go to the, let me cancel. Let me cancel and see if I can go to my main screen here. Okay, I got here. So I need to go to this. Oh, how do I minimize this one? Okay, I do not need this. Huh. Sorry. Okay. Just 1 second. 1 second. I'll be there. Okay. Okay. This is what I want to. I am getting my G power here. I wanted to really show you how I go there, but am I with you?
You are with us, but we can't see the screen yet.
Okay, yeah, I will show you in a minute. So let me see. Okay. Telling me join meeting. It is telling me join meeting.
No,
Okay.
Share screen, something like that. Share content.
Right. I'm trying to check that screen where I was. Yeah, here it is. Sorry. Okay. Sorry about this. Okay. Okay. So share. I don't know. Is this one?
Mhm.
Let me see. I think that is the one.
Yeah, it's
Right.
coming up.
Okay.
Yeah, we can see it, G power 3.17.
Okay. So let me close it and let me show you how I get to there. Okay.
Okay.
Because now I see my screen. So this is my basic screen. So just double click. When you download this, there will be icon like this. You'll double click and you'll see the screen. Now, one problem with the G Power is that you have to get it up and up to get to see the bottom of it. Okay, so you see the bottom. It says calculate XY. Do you see that last part end of this? Sometimes
Yes, you can see that.
you can see that. Barely you can see it. I know, but we need to see that. That's why I'm taking this up. Okay. So here, okay, any number. Let's see any number. Forget about that 21. So when you want to do a sample size for cross-sectional study, here you see test family. So default is t-test. Do you do any t-test for cross-sectional study? Yes or no? Do you do any t-test for cross-sectional study? No, thank you. No. So we will not use this default. What we use, it's called, we are not using f-test, t-test, g-test, or chi-square test. This is the only thing by exclusion is exact. Actually, why it is exact? We have an exact number for proportion that we are using to calculate sample size for cross-sectional study. That's the simple answer I found out. Okay, so so there is a drop-down menu. You will use exact. Please remember, and that's in your handout. Okay, so I use exact. The second thing is we are not doing any correlation. Why no? Is this is the default. So drop-down menu is the one you see proportion and difference from constant. Okay, that's the one you have to use. Why? Because there is a constant number, which is the exact proportion. We are trying to get the difference up from the constant, and it is also a proportion. So your drop-down menu is there. You use the third one. It's always, it will be the third one for cross-sectional study. Okay, so use that one. So two things you have changed: test family, statistical test. Number three, do not change anything here. Number three is tail. Sometime and very rarely we used one tail test. Let me tell you, when your outcome goes to only one direction, then only you can do one tail test. Most of the time in real life, we are not 100% sure that my outcome will only be increased or only be decreased. Okay, like if we do a clinical trial, for example, okay, if you do a clinic, I have done one study in Bangladesh using iron supplementation, like your Professor Hamid Jan did a lot of studies with iron supplementation. So in my cohort is a children. So we studied 500 children and followed them over time. It's a cohort study. And we studied their growth, number one, and number two, morbidity. So growth means linear growth. It can be weight or height. So both. So linear growth, if you take it, linear growth in children will be increased or remain the same, but it will never go down. It will not be decreased in children. In older people like me, yes, height can be decreased, okay, because of collapse of the vertebra, okay. So shortening of vertebra can cause a decrease of your height, but children, it doesn't happen. So you can do one tail test if you study height. But if you study morbidity, effect of iron on morbidity of children, morbidity, let's say pneumonia will be less or more for giving iron. You are not 100% sure. In fact, in our study for diarrhea, we had decreased diarrhea, but increased blood dysentery. Okay, so you never know for sure. So in that case, two-tail. Most of the time, two-tail. Okay. Okay. So I do not change here effect size, alpha error. That would be changed later. Okay. But alpha error is 0.05, which is normal, constant. Okay. And then power, you see, default is 0.95, 95% is too much. I will make it 90%. Okay, that's it. I'm not changing anything else. So 1 is here, exact. 2 is a statistical test. 3 is changing the tail to tail. Change the power. That's all. And then press this button, determine. Press this button. For first time, most of you are doing this first time. So please remember the steps I mentioned. And these are all written in my handout. Determine. Then you get this another window. I said we are not calculating odds ratio or ratio of two things. We are calculating difference. So I'm changing here. Please note, I'm not using odds ratio. I'm not using the ratio of the two things. I'm using the difference. So this is what I'm changing to. Okay, good. So what was the rate that I used? 21%. So I'm changing this number, 0.21. Okay, 0.21. Okay. So I said my effect size would be 5%, right? D, I used 5%. So now, if I'm studying the rate of under this is malnutrition, so I want to reduce the rate, right? I don't want to increase the rate, okay, in my study. So children, 21%, this is the rate I got for P1. P2 would be 5% less than that. So why less? Because I want to decrease it. For some reason, if you want to increase the P2, for example, rate of exercise, okay? Okay, let's say 21% are doing exercise daily or 5 days a week, okay? I want to increase that. And the D effect size is 5%. In that case, your P2 would be 5% more than that. So please remember, less or more depends on what you are studying. You are decreasing the rate of malnutrition by 5%. So 0.05, 0.21, I'm using my calculator, 0.21 minus 0.05. 5% is 0.05. You get 0.16. So 0.16 is your P2. Any question about this so far? Please use your chat box. Any questions at this point? Just what I mentioned about this, nothing else. Please repeat you said repeat P2, P1 again. Is that okay? So I repeat that. First of all, I wanted a difference. I changed odds ratio to this one. Everybody okay with that? I use my P1 from the data that I got, 21%. 21% means 0.21. I want to decrease that. And the effect size is 5%. 5% is 0.05. 0.21 minus 0.05 is 0.16. That's P2. Are you okay? Please say okay if you, good, thank you, thank you. So this is the most important part. And then you will use this one. First you can check by you pressing calculate, and then you will transfer that to this window. So first one says calculate, next one says calculate and transfer to main window. Main window, my cursor moving here, this is my, on the left, that's my main window. So you can first check it, calculate, and that shows negative 0.05. So you are doing right. You are calculating something with 5% reduced rate. That's, you make sure that you are using the right numbers. Then you transfer this to the main window. Are you ready? Yes, ready? You're so far okay? Ready? Say yes or text. Or if you want to know more, okay, thank you. So I press this, thank you, thank you. So I press this and you'll see some changes, magic. Okay, get ready for the magic. Okay, now I see here, effect size 0.05. Alpha, this. Make sure beta or power is 90%. Don't worry about this 0.21 because that number comes from here. That was the rate constant proportion. That is the constant proportion. That is the constant proportion, 0.21. That we are calculating to get the sample size. So now you use calculate. Then you will see the magic. Oh my God, magic is coming here. Okay. So your magic number, total sample size is 646. That's it. Oh, you don't worry about this too. Just worry about the total sample size. Okay. And you see your actual power is little more than 90. That's fine. Okay. Actual beta is I said 0.05, but it's little less than that. Little less than that. So this is the actual number. You don't have to worry about this number. But I will show you another important thing. So please write down the steps, or you have the steps actually in my PowerPoint. So your calculated sample size for this study would be 646. And you have one group, you do not multiply with 2 or 3 or anything because you do not have more than one group. Is that okay? Please say yes. Is this okay so far? Good. Thank you. Thank you. Now I'll show you another very important and interesting thing about PowerPoint. That's what I like about this PowerPoint, I mean G-Power. You see at the bottom, XY plot for range of values. There is one called option. In the middle, it says X-Y, XY plot. That's the one I will click. So I'm going to click on that. Click on that. I get another window. Okay. This is, some people want to know what is your power. Do a power calculation. Do a power calculation. This is what they mean. Okay. So you'll draw power, draw plot. Nothing changed. Don't change anything. Just draw plot. This is what I really like it. Really like it. Okay. Now you see this graph. Let me interpret that. If this is the x-axis showing power, y-axis is showing total sample size. Okay. So here we are. If it is 90% power, then sample size is here. What is little between 650 or little less than that, something like that. Okay. And then if we really check, the number is 646. 646. So it is showing here, if it is 90% power, then it is 646, close to 650. That's what I see from here. If you do 95%, can somebody tell me, if I do 95% power, what would be my sample size? Will it be bigger, larger? Yeah, close to, yes, thank you, close to 800. Thank you so much. Little less than that, maybe 798 or something. Okay, so definitely, yes, thank you, more. Now, somebody tell me, if I do 80% power with the same study, 80% power, what would be my sample size? A rough estimate, about 500, little less than that. You can say little less than 500. Okay, so exact number could be 488 or 498, something like that. We don't know. Okay, but we can calculate that. But this, so power calculation, these graphs tells you what is your power and what would be your sample size. Do you like it? Good. So Yusuf Sen, thank you. So other thing you can do, what I really do, go to File and Save Plot. So if I save plot, where I'm saving the plot, I'm saving to my desktop, and I use a name, just let's say is a test power, just number, just something that I can find out. Okay, in the desktop. Okay, so I have saved that. Okay, there. I want to move that, or I cannot do that. So I can close this, and also close this one. Going to see that anymore. Okay, I don't want my cursor. I cannot go there. I want to check. Yeah, I go there. Okay. Okay, this is, so test power. Okay, so I check everything, cross. Test power. And what I really do, normally I copy this and paste in my project. So I copy this and you can paste it in the project that you write your power calculation. That's the beauty. That's the beauty. You can use it anytime. Just save it, and that will tell you exactly. So let me go back to, don't save it, okay. Let me go to my PowerPoint again, or then I can show you okay, before I go there, let me open my PowerPoint. Okay. Okay. So let me share my PowerPoint. So you see my PowerPoint again? Okay, so this is what I did. We use these steps, exact, select proportion difference from constant. We change the tails, selected two tails. Okay. Selected two tails. Do you see this? Yes. Please write down. Do you see my slides? Please write. Okay, thank you. Thank you, Yosef. So this is the steps we did, exact. Then we selected the statistical test, proportion, difference from constant, tails, we changed to two tails. We checked alpha, it was 0.05. We changed power to 90%, then clicked on determine. Then we got another window. We selected the difference. There was ratio, there is another. We selected the difference one. And then we changed the number for P1, 0.21, because that's the number we got from the previous studies. We selected the effect size, 5%. P2 would be 5% less than P1 because we know that the nutritional status we want to malnutrition, we want to decrease the rate. Okay. Then we use calculate transfer to main window. Then we found the result. Now, whatever number you have, I said dropout rate is 20%. You add that to the total. Okay, you calculated your sample size, 646, but if you have 20% dropout, 20% of this is 129. You add that. This is your actual sample size required for this study. Everybody okay? Everybody okay? Any questions? I have another example. I don't want to go through that because if you are okay, we can stop here. We already have 1 hour, but I have another example next. And I have gone through this XY plot, how to draw plot and interpret that. We have done this, but we have another exercise that also data from Malaysia, that Professor Hamid Jan's group actually did that study. And if you use that data, 33% of adolescents were deficient in vitamin D. I think this is another study, not Dr. Hamid Jan's study. It's a different study. So 33% of adolescents, we wanted to know the vitamin D deficiency in adolescents. The rate is 33%. That's the baseline data. We'll do 95% confidence, not 90%, but 80% power. Dropout not 20% or 25%, we will use 15%. So all you have to do, use those data, same way, select exact, select statistical test, two-tail, alpha saying, change the power to 80%, 1.8, press the button determine, plug in the numbers 0.33 for P1. In this case, 4% difference. So 4% less than 0.33 is 0.29. That's P2. So you plug in those two, you get the sample size, add 15% dropout, 159. This is 15% of this number is 159. You add that, your total sample size would be this. Exactly, you can practice that with the same. Okay. Now, if you want to increase the effect size for same data, like instead of 4%, if you use 5%, so other things are remaining same, your total sample size would be less. So if you increase the effect size is wider, then your effect size, your total sample size would be less. Okay. If you want to increase it further to 6%, you see total sample size is further less. So depending on the effect size, we do not really want to make a big difference from the real value. If you make a real difference, big difference, like 6% instead of 5 or 4, then your sample size will definitely be much less, almost half. Okay, almost half. So as a statistician, your job, I tell you, my students, always, please remember, your job is to really do a realistic number. If you use 6%, yes, you can save a lot of money by calculating, by using almost half of sample size that you really need. Is it good? I should say no. You will be realistic. What is really good for the population? You should do a study that is good for the population. So, and now your question and answer session. I'm done with this, and then I stop sharing. Let me go there. Okay. I stop sharing. I go back to my original. Okay, here. Tell me. Thank you so much for your patience. And now you can ask me any questions. Again, I have a question. Yes.
Please, doctor, I make a pre-test, post-test research for my thesis. Okay,
Mm.
For one group only. I have three domains: the knowledge and the practice and the confidence. I will
Your
do.
sound is very, very, I cannot hear properly. You are doing some project, you said.
Yes, quasi-experimental, quasi-experimental. I have three domain: knowledge, practice, and the skills. Okay.
Okay.
Same group. I will do intervention and pre-test, post-test questionnaire. Okay. I prefer to use links on rank tests.
हाँ मंगा दे यार
Okay.
पैसे मुझसे ले ले
Okay. We are not going there.
फोन के मेरे पास
Everything
कुछ है नहीं कल मैंने देख के रखी फ्रिज में मुझे इतना बड़ी फीलिंग आती है
There is some noise, doctor. Sorry.
I hear many voices.
मंगवा दे यार पैसे मुझसे ले लेना अभी दे दूं
Okay,
पैसे 1000 दे दूं
please
आंटी
no
के नाम
side.
पे ना जैसे अपनी मंगा दे ना डब्बी
Please
साल भर
mute.
रखने के लिए आटा भी रख लेती हूँ कभी कुछ रख लूं मेरे पास एक डब्बा भी नहीं है सोचो
Okay, this kind of question
चलिए मंगवा देना पैसे
for
मुझसे ले लो
everybody, you send me your email.
ये तुम लोग मंगा
I'll
देना सारे
answer
डिफरेंट
to
साइज
you
के ना तो बड़े हो
because
ना तो छोटे हो
what I wanted
चलिए
to
मंगवा
know
देना
people
पैसे मेरे
today is about
हाँ ये पक्का
this
वादा लेना आंटी से
I
one type of calculation. Other things, if you
अल्लाह
have
सच्ची
any
मैंने पूरी
other
कल
type of issues, please write to me. Wilcoxon rank sum test is different, not
that's
this. Okay,
okay. I will inshallah contact with you by
write to me.
email. Thank you.
Thank you.
Thank
Thank you. I'll need when you write to me, I'll need some of your information like, your questionnaire, little bit information. Without that, it's really hard to make a decision what type of test you'll be doing. Although you said you're using Wilcoxon ransom test, but I have to see if that is the appropriate thing or not. Okay.
Okay, Doctor. I will contact with you, inshallah. Thank you.
You're welcome. Any other questions related to this, what I have described today? Anybody, please? How to calculate mean and standard deviation. Now, this is again another not related to today's class, because mean and standard deviation is not done for this cross-sectional study. Mean and standard deviation I'll be using for clinical trials or community-based trials, okay? So that is different. I'm not showing it using G-Power. I'll be showing it in another lecture, if possible, by using formula, and I'll demonstrate everything step by step. That's totally different. It will take another 1 hour. Yeah, you said, yes, I can give lecture. Let me see what other important things are pressing for this lecture series, because there are some target things to do that I was told to do for your lecture. I'll check what other important things that I have to do before yes, interventional study or clinical trial. Those kind of things are really important. Case control study, cohort study, everything is important, but there's not a clear one answer for today. There are many things we can go talk about sample size. Also, I know important, as you said, linear regression, everything is important, but not everything can be covered in my basic course that I'm teaching you. And there is an outline that your university wanted me to go over. I'll try to finish those things first. There is a priority for this kind of lecture. Some people can be PhD students, some people can be just beginning masters. So we should do something for everybody. Okay, that's what is the goal for this university lecture series. Please be patient, but if you have questions, you can write to me. Thank you. Is that okay, Dr. Professor Hamid Jan?
Okay, I think that is, you can see you can see, Prof.
Yeah.
There are a lot of interest.
Okay, so based on the interest, maybe I can offer another sample size, and if Professor Hamid Jan wants me to do that, he's the main person to control everything, because he does that. Actually, he talks with the upper administration what they really want me to do, and then he communicates with me.
Yeah,
Okay?
I think we will discuss with you as well if there is any related topic that we can continue from today for next year's next lecture. Okay, bro?
Okay, sure. I'll talk with you.
Okay. Yeah, I think we had a very interesting session with Prof. Amal today, and everybody benefited from this. We will keep in touch. We will keep each other updated. I think for those who are interested with the slides, you can email Puan Wan Suryati, and she will share with you the slides. And if anything, we can she said we will upload the session in the PPSK YouTube channel as well. Okay, all right. Thank you very much, Prof. Amal, and everyone for your active participation.
Thank you so much, and
Okay.
have a nice day. Nice day. My night time.
Yep. Yes.
Okay.
You should go to
Bye-bye.
bed.
Oh, yeah.
Okay, bye.
Bye. Bye, everybody. Bye, everybody.
Bye.
And my heart is with you because I began my, people talking with people in Malaysia first, and then Hong Kong, then Kuwait, other countries, but always Malaysia is in my heart.
Yes. Thank you, Prof. Okay.
Bye.
Bye-bye.
Bye.